All right, so we're going to talk about Coulombs law. It's pretty straightforward. In all honesty, it's a plug and chug type equation. That does not mean that there aren't some curveballs and some things lurking conceptual that can be done. But for the most part, it's really a plug and chug type scenario. So we're just going to talk about the basics. I guess I should have gotten a pen out to write with. Oh, I'm good to go. Never mind. So let's have some charges, okay? So let's have a +3 microcoulomb charge over here, and then let's have a -2 microcoulomb charge living over here. Now, first thing you'll notice is that they are not both in the x-plane or the y-plane, they're kind of diagonal. But we really don't care because the only thing that we do care is how far away are their centers. Okay, and that's actually what we're going to be solving for here. So we know the two charges, and let's say that we know that the electrostatic force between the two is, I don't know, I'm going to pick up a random number here. Let's go with 0.3375 newtons. All right, so that's the force that they're feeling of attraction. So they're being pulled towards each other because they have opposite charges. And we're going to try and figure out, well, how far apart are they at this point that we kind of took this measurement? So we need to know the charge of each object. And so it doesn't really matter what order you put them in, but our first Q value is a +3 microcoulombs. What that means is that it is 3 times 10 to the -6th coulombs. All right. Now you'll notice I'm also not going to deal with the plus and minus signs here because I'm going to let my conceptual understanding do that for me. I know that because they're opposites, they're going to be drawn towards each other. Okay. So I'm not going to worry about the plus minus in my equation because I understand its outcome over here conceptually. So let's see, the other charge, Q2, is then 2 times 10 to the -6 coulombs. And we want to know how far apart are they. Well, the equation that we're going to be using is this guy here, Coulomb's law. So electrostatic force is equal to K Q Q. Now you can put this as a 1 and a 2. It doesn't really matter. You'll usually see me write QQ over R squared. Now this K value is just a constant. So it is always equal to 9 times 10 to the 9th Newton meters squared per coulomb squared. And it's just there to make the math work out so that these ideas of charge will work with the idea of what's a Newton. Okay, so it's just kind of a mathematical thing to get everything to talk to each other. So we get a common language. So now all I got to do is a bunch of substitution here. So I know the electrostatic force is 0.3375. K is always 9 times 10 to the 9th. 1Q is 3 times 10 to the -6th. And the other one is 2 times 10 to the -6th. Yeah, this is not a pretty equation. Not going to be a lie about that. Over R squared. Now, when you do this in your calculator, one of the things I recommend is that when you write these out in your calculator, I would put 2, then use that double E function. So it would look like that in my calculator, 2e -6. Same with this. This would be 9e 9, 3e -6. If you punch that in there in your calculator instead of trying to do the exponent button, it's going to really help out. I'm not going to lie. So now it's just a matter of algebra. Okay? So we would multiply both sides by r squared, bring this over here. So this times this times this divided by that guy. And then we have to square root it to get the opposite of this. We will end up with an answer of, let's see, what radius do we get? Do the math, and you should get 0.4 meters. Okay? So again, just for the algebra, this times this times this divided by that guy, and then you just take the square root of that, and that'll get you your answer. All right, so that's the ideas. Like I said, the calculator issue is kind of a big thing. If someone were to ask, what direction are they being pushed or pulled in, go to the conceptual element. That's why I always make a drawing and label the charges on my drawings. And yeah, it's just doing a lot of math. So that is Coulomb's law. So I hope you enjoyed as much as I did, and be prepared to use a lot. It's a lot of fun with a calculator. So enjoy your time with physics and, other things too.